In the beginning, there was darkness. Not the darkness of closed eyes or midnight's familiar veil, but a darkness that filled everything. The only darkness there was. No shadow, because shadow needs light to define its edges. No night, because night is only the word we give to the turning away from a star. This was the universe before stars existed, suspended in a cooling fog of hydrogen, waiting in silence that had never known sound. The cosmos breathed without rhythm, drifted without direction, and somewhere within that measureless dark, time moved forward, carrying no witness, no reflection, no shine. If the universe could feel its own emptiness, what did it sense in those ages before the first light broke, before anything burned, before photons learned to travel freely, when the whole of existence hummed at a frequency too low for sight? What was the texture of that cosmic night? The waiting had its own temperature, its own color that wasn't color. For roughly 380,000 years after the universe bloomed into being, light existed but could not travel. The cosmos was too dense, too hot. Matter and radiation locked together in a glowing plasma where photons ricocheted endlessly between particles, trapped inside an opaque fog. Then came the era scientists call recombination, when the universe cooled enough for electrons and protons to bind into neutral hydrogen atoms. Suddenly, photons could slip free. Light, for the first time, moved through space unhindered. The afterglow we now detect as the cosmic microwave background, that whisper from the edge of the visible past. But this moment of liberation was also a kind of goodbye. Once, the ambient glow faded. Once those ancient photons scattered into the expanding dark, the universe entered a span researchers call the cosmic dark ages. For hundreds of millions of years, perhaps as few as 100 million or as many as 400 million, no stars yet existed to break the blackness. Hydrogen drifted in slow currents, drawn by gravity's patient hands into regions that would someday collapse, but not yet. Not for a long, quiet time. Everything drifted in the space between. Most cosmologists agree that during this epoch, the universe was not entirely featureless. Tiny density fluctuations, quantum variations imprinted in the first fraction of a second, rippled through the hydrogen fog. Where the gas gathered more thickly, gravity tightened its hold. These were the seeds, the first whispers of structure. Not yet galaxies, not yet stars, only clouds of matter beginning to listen to their own mass. Evidence from observations of distant quasars and simulations of early structure formation suggests that the first stars, called population 3 stars, ignited sometime between 100 and 250 million years after the beginning. They were massive, brilliant, burning through their hydrogen fuel at a furious pace, but they had not yet been born. Before them stretched an age that knew no dawn, no twilight, only the gradual dimming of the universe's infant light, and then the dark. The hydrogen remembered only temperature, only the slow fall toward cool. In that lightless interval, time moved as it always had, but without punctuation. No sunrise to mark a day, no star's lifespan to measure duration. The universe expanded steadily, space stretching, carrying the clouds of neutral hydrogen farther apart, even as gravity tried to pull them inward. Some researchers propose that this was the longest night the cosmos would ever know, the pause between the first flash and the age of illumination. The Dark Ages were not a failure or an absence, but a preparation, a held breath before the first scream of fusion. Imagine the density of hydrogen in those early clouds, not yet hot enough to ignite, but gathering particle by particle into clumps that would eventually become massive enough to compress under their own weight. The physics were simple. Gravity pulls, gas heats when compressed, and if the mass is sufficient, the core temperature climbs until hydrogen nuclei overcome their mutual repulsion and fuse into helium. But reaching that threshold took time, measured not in years, but in the slow drift of ages. Noon held steady over an ocean that reflected nothing. Consider the nature of darkness in a universe without obstacles. On Earth, night falls because our planet turns away from the sun. Shadows form because objects block light's path. But in the cosmic dark ages, darkness was not the absence of light in the presence of blocking matter. It was the condition of space itself. The only photons traveling freely were the stretched, cooling remnants of the Big Bang's glow, their wavelengths pulled longer by the expansion of space, their energy diluted across an ever larger volume. By the time 10 million years had passed, these photons had redshifted into the infrared, invisible to any hypothetical observer. By 100 million years, even those faint traces would have been difficult to detect. The universe was not a void, but a volume filled with matter, hydrogen and helium in nearly perfect proportion, the lightest elements forged in the first 3 minutes, yet it emitted almost no radiation. It was a place of potential, of latent energy waiting for gravity to kindle the first flames. The clouds thickened in silence. Where the hydrogen gathered most densely, the process of collapse accelerated. Slight overdensities attracted more gas. As the clouds contracted, the gravitational potential energy converted to heat. Computer models of primordial star formation suggest that the first collapsing clouds reached masses perhaps 100 to 1,000 times that of our Sun before their cores grew hot enough to ignite fusion. These stars, never observed directly, but inferred from the chemistry of later stellar generations, would have been giants, blue-white, blazing with ultraviolet light, living only a few million years before exploding or collapsing into black holes. But before they could form, the gas had to cool as it compressed, radiating away energy so that gravity could continue pulling inward without the pressure of heat pushing back. In the modern universe, elements like carbon and oxygen facilitate this cooling, emitting radiation efficiently. But in the Dark Ages, only hydrogen and helium existed. The cooling mechanisms were slower, less efficient, which is why the first stars took so long to form and why they grew so massive once they did. Perhaps time itself was learning how to pass. And beyond what the data can show, beyond the simulations and the careful equations, lies the question that belongs more to wonder than to measurement. What was the quality of that darkness? Not how long it lasted or what processes unfolded within it, but what it meant, if meaning is even the right word, for the universe to exist in a state of pure potential. There were no eyes to see the dark, no minds to mark its passing. The universe moved forward, matter and energy evolving according to physical law, but without witness, without anyone to ask the question. Does an event happen if no consciousness observes it? The Dark Ages remind us that, yes, it does. The laws of physics need no audience. Gravity pulled, gas cooled, the seeds of stars gathered mass in the blackness, and the universe prepared itself for light, without knowing that light was coming. It was not waiting for permission. Some physicists speak of this period as a kind of phase transition, a cosmic adolescence between the hot, dense early universe and the structured cosmos of galaxies and stars. Others describe it in more poetic terms, as the universe's longest meditation, a span when complexity was gestating but not yet born. The clouds of hydrogen drifted through space that was itself expanding, and in their slow collision and merger, they were writing the future. Every star that would ever shine, every planet that would ever form, every atom in every living thing, all of it depended on the Dark Ages ending, on the first stars igniting. But the Dark Ages were not merely a prelude, they were an era in their own right, an epoch when the universe existed in a state it would never know again. Matter everywhere, energy diffuse, and no fire yet kindled to transform hydrogen into heavier elements, to flood space with radiation, to carve out regions where complexity could flourish. Everything waited for its own arrival. The first stars, when they finally formed, did not appear everywhere at once. Cosmologists believe they emerged in scattered pockets, wherever the largest overdensities had managed to collapse and ignite. Each new star was an island of light in a sea still overwhelmingly dark. The ultraviolet radiation they emitted began to ionize the surrounding hydrogen. carving out bubbles of transparency in the neutral fog. Slowly, over millions of years, these bubbles grew and merged. The universe transitioned from neutral to ionized, from opaque to clear. This process, known as reionization, did not happen overnight. It unfolded gradually, unevenly, as the first galaxies formed and the first generations of stars lived and died. By about 400 to 500 million years after the beginning, most of the hydrogen in the universe had been ionized again, and the dark ages were over. The cosmos had invented light, or rather, matter had arranged itself in such a way that gravity could kindle fusion, and fusion could produce photons that traveled freely once more. Dusk settled over the ledger of a universe learning to shine. But here is where the story bends back toward strangeness. The light that ended the dark ages was not new in the sense of being created from nothing. Photons had existed since the first moments of the Big Bang. What changed was the structure of matter, the arrangement of hydrogen atoms, the density and temperature of collapsing gas clouds. Light did not need to be invented. It needed to be released again in a new form. The photons streaming from the first stars were different from the cosmic microwave background only in energy, in wavelength, in origin. They were born not from the smooth expansion of the early universe, but from the violent fusion in stellar cores. And yet they were made of the same substance, if photons can be said to have substance. They were excitations of the electromagnetic field, ripples in the fabric of space itself, carrying energy from one place to another at the only speed that matters in an expanding universe, the speed of light. The universe had always known how to make light. It simply had to remember. Some philosophers of science suggest that the Dark Ages represent a kind of cosmic amnesia, a period when the universe forgot what it had done in its first moments and had to rediscover luminosity through the slower, more patient work of gravity and matter. Others reject this anthropomorphism, insisting that the universe has no memory, no intentionality, only the unfolding of physical law. Both views carry a kind of truth. The hydrogen clouds did not remember the hot, dense plasma they came from, but they carried within their motion and distribution the imprint of quantum fluctuations from the earliest moments. In that sense, the past was encoded in the present, waiting to express itself. When the first stars ignited, they were not inventing something new, but activating a potential that had always existed. The capacity for light was written into the properties of hydrogen, into the strength of the nuclear force, into the curvature of space-time itself. Perhaps invention is only memory by another name. Consider the moment just before the first star ignited. A cloud of hydrogen, perhaps 100,000 times the mass of our sun, had been collapsing for millions of years. The core grew denser, hotter, the temperature climbing from a few hundred degrees to a few thousand, then hundreds of thousands. The atoms moved faster, collided more frequently. At some threshold, around 10 million degrees, the hydrogen nuclei began to fuse into helium, releasing energy in the form of photons and neutrinos. For the first time in hundreds of millions of years, the universe had a local source of light. But the star itself was still shrouded in the cloud of gas from which it formed. The photons had to fight their way out, scattering through the dense envelope, absorbed and re-emitted countless times before finally breaking free into the surrounding dark. When the light finally emerged, streaming outward into space, it illuminated nothing. There were no planets yet, no dust, no other stars nearby. The photons simply traveled, expanding spherically at the speed of light, dimming with distance, until they reached the neutral hydrogen beyond the star's immediate neighborhood and began to ionize it one atom at a time. The first light touched only emptiness. And what of the dark itself? Did it resist? Did the hydrogen clouds, stable and cool in their neutrality, struggle against the ionizing radiation? Of course not. Matter has no will. But there is a kind of tension in the physics. Neutral hydrogen absorbs ultraviolet photons efficiently, each absorption stripping an electron free and leaving an ionized proton. But ionized hydrogen is transparent. Once ionized, the gas allows photons to pass through unhindered. So the spread of light through the universe was a self-reinforcing process. Each ionized atom made it easier for the next photon to travel farther. The bubbles of ionization around the first stars grew exponentially, merging with neighboring bubbles until the whole universe transitioned from dark to clear. It was not a battle, but a transformation, a phase change like ice melting into water, inevitable once the threshold was crossed. Time exhales. When stone forgets its shape, does it still remember heat? When a photon travels for billions of years, redshifted by the expansion of space until its wavelength stretches from ultraviolet to infrared to microwave, does it carry with it any trace of the star that emitted it? The answer is yes and no. The photon's energy decreases with redshift, but its trajectory, encoded in its direction and polarization, preserves information about its origin. By the time we detect the light from the first stars, or rather from the galaxies they formed, we are not seeing the stars themselves but the fossil record of their radiation, stretched and weighted by 13 billion years of expansion. The universe has grown so much since those early epochs that the first stars, if they still existed, would now be separated from us by distances far greater than the light travel time. We see them as they were, not as they are. We observe the past, and the past is a country of perpetual night, slowly giving way to scattered fires. The scale humbles all telling. There is a recursion in this story that feels almost like déjà vu. The universe began in light, the blinding opaque plasma of the big bang, then went dark as it cooled, then lit up again as stars formed. Birth, darkness, rebirth. Or perhaps light, forgetting, remembering. The cosmic microwave background is the afterglow of the first light, cooled and stretched into invisibility. The light from the first stars is a new beginning, but it carries echoes of the old. And here, billions of years later, we, made of atoms forged in stars that came after the first stars, look back toward the origin and try to reconstruct the night that preceded the dawn. We are the universe attempting to remember its own infancy, to piece together the dark ages from clues scattered across the sky. Every observation of a distant galaxy, every measurement of the cosmic microwave background, every simulation of early structure formation is an act of archaeological cosmology, a digging into the past to find the moment when everything changed. Oceans rose, continents wandered, time kept breathing. But we are not heroes in this story, only witnesses arriving unimaginably late. The first stars lived and died before our sun was born. The Dark Ages ended more than 13 billion years ago. By the time Earth formed, the universe was already ancient, already filled with galaxies and heavy elements and the complex chemistry that would allow life to emerge. We are latecomers to a narrative that began without us and will continue long after we are gone. And yet, in our brief window of consciousness, we have managed to look back toward the origin and see, faintly, the structure of the early universe. We can calculate the temperature of the cosmic microwave background to 5 decimal places. We can model the collapse of the first hydrogen clouds. We cannot observe the Dark Ages directly. They left no light for us to detect. But we can bracket them, infer their duration, understand the physics that governed them. In doing so, we touch something that existed before stars, before light, before any structure that resembles the universe we know. The belonging is retroactive, but real. Turn the scale inward now. Every atom in your body was once part of the hydrogen clouds of the early universe, or part of the stars that formed from those clouds. The carbon in your cells was synthesized in a stellar core, possibly in one of the first generations of stars, then expelled into space by a supernova. The oxygen you breathe, the calcium in your bones, the iron in your blood, all of it was forged in fusion reactions and scattered across the cosmos to eventually gather into a solar system, a planet, a living thing. You are made of star stuff, as Carl Sagan famously said, but more precisely, you are made of the ashes of stars that ended the Dark Ages. The universe invented light, and in doing so invented the possibility of you, not intentionally, not with foresight, but through the inexorable workings of gravity and nuclear physics and time. You are an echo of the first light, a descendant of the moment when the universe woke to its own potential. The recursion loops inward until it becomes personal. And perhaps this is where the story meets sleep, where the cosmic scale touches the intimate one. To fall asleep is to enter a kind of personal dark age, a span when consciousness dims and the mind drifts through unstructured thought, dreams that have no author, images that flicker without external light. Sleep is not a shutting down, but a different mode of being, a state where the brain reorganizes, consolidates, prepares for the next waking. It is the night between days, the pause between efforts, the span when we forget ourselves, and then, in the morning, remember. The universe did something similar. It cooled, it drifted, it waited in the dark for the conditions to align, and then it kindled the first stars. The Dark Ages were not a failure, but a necessity, a time when structure could coalesce without interference, when gravity could do its slow work. And when the first light broke, it was not the end of something, but the beginning of everything else. We fall asleep inside the same recursion. Look up on a clear night, away from city lights, and you can see stars. Not the first stars. Those are long gone, collapsed into black holes or exploded into supernovae billions of years ago. But you can see their descendants, stars like our sun, or younger or older, scattered across the galaxy. Between them, the dark persists. Space is still mostly empty, still mostly black, but now the black is punctuated by light. The universe will never again be as dark as it was during the cosmic dark ages. Even as stars die and new ones form more slowly, even as the expansion of space accelerates and galaxies drift apart, the light that has already been emitted will continue traveling, fading, but never fully disappearing. The universe has crossed a threshold. It has learned how to shine, and it will not forget. Twilight holds the horizon. Return now to the image of the beginning, to the darkness before stars. Imagine it not as a void, but as a fullness, a space dense with hydrogen, humming at a frequency below perception, waiting in a patience that had no sense of itself. The temperature was falling, the density thinning, the universe expanding steadily, and somewhere within the vast, dark, tiny density fluctuations were growing, fed by gravity's gentle insistence. There was no loneliness, because there was no consciousness to feel alone. There was no boredom, because there was no mind to grow restless. There was only the unfolding of physical law, matter arranging itself according to rules that had no exceptions, no preferences, no mercy. And yet, within that strict determinism, something like creativity emerged. The first stars were not planned, but inevitable. The Dark Ages were not a mistake, but a precondition. The universe invented light by learning how to collapse, how to heat, how to fuse. The same wind carries new embers now. In the last moments before the first star ignited, the core of the collapsing cloud reached the critical temperature. Hydrogen nuclei, moving at incredible speeds, collided and fused. Energy released, pressure built, the collapse halted, reversed. The star was born. And in that instant, the Dark Ages did not end everywhere. Only there, in one small region of space. The light spread slowly, ionizing the surrounding gas, carving out a sphere of transparency in the neutral fog. Other stars formed nearby, then farther away, then across the entire universe as the first galaxies took shape. The transition from dark to light was not a single event, but a cascade, a feedback loop, a phase change that propagated across the cosmos over millions of years. By the time it was complete, the universe was unrecognizable from what it had been. The Dark Ages had become legend, a story told in the red-shifted light of distant galaxies, in the faint glow of the cosmic microwave background, in the calculations of cosmologists trying to reconstruct what happened when no one was there to see. Darkness gives way to scattered shine, then more. Now let the story soften. Let the technical details fade like the last stars before dawn. What remains is the image, a universe in darkness, waiting. Not knowing it was waiting, but waiting nonetheless. And then, fire. Not all at once, but slowly, in scattered pockets, light returning to a cosmos that had been dark for longer than stars would ever shine. The first photons from the first stars traveled outward into the black, and the black did not resist, did not flee, simply transformed, atom by atom, from neutral to ionized, from opaque to clear. And the universe, having invented light once in the Big Bang and then forgotten it, remembered again how to glow. The light was always there, learning to be free. We are 13 billion years downstream from that moment, suspended in a galaxy that is the descendant of the first structures, made of atoms that cycled through stars we will never see. The night sky above us is the same night that existed during the Dark Ages, but now it is filled with light too faint for our eyes to see individually, but collectively painting the black with a glow. The cosmic microwave background bathes us in photons from the era of recombination, stretched into invisibility, but still present, still traveling. The light from distant galaxies carries information about the universe when it was young, when the Dark Ages were ending, when the first stars were reionizing the hydrogen fog. We are surrounded by light that has been traveling for most of the age of the universe, and we mistake the black between the stars for emptiness, when it is actually a canvas, a record, a map of everything that has happened. And the question the title asked, what was the night like when the universe invented light, finds no single answer, because the night was many things. It was long, it was silent, it was full of potential and empty of fire. It was a span of time so vast that our sun could have lived and died 1,000 times over before the first star formed. And it was also brief, a tiny fraction of the universe's total age, a pause between the initial flash and the age of structure. The night was the condition from which everything emerged. The night was the canvas on which gravity painted the first stars. The night was not the opposite of light, but its mother, its necessary precursor, the stillness before the first breath. Everything returns to the dark between thoughts. The hydrogen drifts even now, in the vast spaces between galaxies, slowly being consumed by star formation, but never entirely exhausted. The universe expands, the light redshifts, the stars age. Someday, trillions of years from now, the last stars will burn out, and the universe will enter a new kind of dark age, one without end. But that is not tonight's story. Tonight, we remember the first darkness, the one that gave way to light, the night when the universe discovered that matter could burn. And in remembering, we touch something older than anything we can see, older than the stars, older than the galaxies, older than the possibility of eyes to witness it. The darkness was patient. The light was inevitable. Close your eyes now and imagine that you are floating in the cosmic dark ages, suspended in a cloud of hydrogen, surrounded by silence. No stars above or below, no horizon, no sense of up or down, only the slow drift of atoms and the even slower pull of gravity. You are not waiting because there is nothing to wait for, no future you can imagine. You are simply present, held in the dark, part of the dark, indistinguishable from it. And then, after an age that has no measure, a light appears, not near you but far away, a single point of brilliance in the black. You do not move toward it. It does not move toward you. But its light spreads, a sphere expanding at the speed of causality, and eventually it reaches you, and the darkness around you begins to glow. You are being transformed, ionized, made transparent. The light passes through you now instead of stopping at you, and you realize that you were never separate from the universe. You were always part of the same unfolding. Breath slows, The mind releases its grip. The first stars are gone. The dark ages are gone. But the pattern remains, encoded in the structure of the cosmos, in the distribution of galaxies, in the faint glow of the microwave background. The universe invented light by arranging matter in such a way that fusion could occur. And fusion is only another word for transformation, for the turning of one thing into another. Hydrogen into helium, potential into kinetic, dark into glow. The universe is an engine of transformation, and we are part of its output. Complex structures that emerged over billions of years from the simplest ingredients. We look back toward the beginning and see the dark ages as a chapter in a story. But to the universe, there are no chapters, only the continuous unfolding of physical law. The telling is only ours. The event belongs to no one. Let the image fade now. Let the hydrogen clouds dim into abstraction. Let the first stars become pinpricks of memory in a mind already half asleep. The universe is still expanding. The stars are still shining. Somewhere, a photon from the cosmic microwave background is arriving at your location, having traveled for 13.8 billion years to be absorbed by the atmosphere, undetected and unmissed. Somewhere, a distant galaxy is forming new stars from the remnants of old ones, continuing the cycle that began when the first stars ended the dark ages. And somewhere, in the vast dark between galaxies, hydrogen drifts, neither ionized nor collapsing, simply existing in the space that is mostly space. The universe breathes even when we forget to notice. What was the night like when the universe invented light? It was the longest night. It was the necessary night. It was the night that carried within it every dawn that would ever break. And it ended not because it had to, but because matter obeys gravity, and gravity gathers mass, and mass heats under pressure, and pressure ignites fusion. The night ended because the universe was patient enough to wait for itself, to let the pieces fall into place, to allow the first stars to form without hurry or haste. And when the light came, it was not a miracle, but a consequence, not magic, but physics, not creation, but transformation. And the universe keeps breathing. So do we.